Hey everyone, welcome back. In today's video, we are going to review differentiating inverse functions. So if I were to put this simply, basically what this tells us is that if you have a point on the graph of a function and you take the inverse of that function and find the inverse point, the slopes will be reciprocals of each other. So I know that's kind of a mouthful, and also the formula itself looks very confusing. So let's take a look at two examples and see what that actually means. Okay, so first let's just take a look at a cubic function here, x cubed, and let's go ahead and just pick a point on this graph. Let's pick the point 2, 8, so you can see that there. All right, now what I'm going to do is I'm also going to graph the line y equals x. This is because we are going to be looking at the inverse function. So it's important to remember that by definition, the inverse function has been flipped around the line y equals x. So that's why we're always flipping y and x, is because of that relationship. So now I'm going to go ahead and plot its inverse function here in blue. So again, notice that beautiful reflection that we have there, right? So the red is our original, the blue is our inverse, and notice how they are perfectly reflected around the black line, which is y equals x. Okay, so now if I were to get the inverse point, I would flip these coordinates. So I would flip 2 and 8, or my x and y values, and then I would get the point 8, 2 here in blue. Okay, so now let's go ahead and find the slope at our original point 2, 8. So in order to do that, I'm going to take the derivative of f, which is just x cubed. So basically f of x equals x cubed. So f prime of x would equal 3x squared. All right, and now again here, my input value or my x value is 2. So I'm going to go ahead and just plug that in here. F prime of 2, and I'm going to get f prime of 2 is equal to 3 times 2 squared, which is 4, and 3 times 4 is 12. Okay, so what that tells me is that at that point, my slope is 12. So here, my m is equal to 12. Okay, so again, now I have my reciprocal point here, which is 8, 2. So now I'm going to call this function g to represent the inverse. So here I have g equals the cube root of x, which is the same as x to the 1/3 power. And now let's go ahead and take the derivative in order to just analyze the slope. So here, if I did g prime, I would get 1/3 x to the negative 2/3 power. And then if I were to just clean this up a little bit, this would be the same as 1/3 times the cube root of x squared. Okay, now my output value here is becoming my input value here. So now I'm going to be plugging in 8 for my x value. So g prime of 8 is equal to this, where of course I'm going to substitute 8 in there, which I apologize, I'm kind of running out of space. So if I get 1/3 times the cube root of 8 squared, and remember, it's okay to kind of flip the order in which we evaluate the exponents there. The cube root of 8 is 2, 2 squared is 4, 3 times 4 is 12. So this is going to be equal to 1/12. So again, this illustrates the key idea here, and this tells us that at this point, at our inverse point, the slope is equal to 1/12. Okay, let's take a look at another example to make sure that all makes sense. Okay, so for this example, let's take a look at y equals the square root of x, which is graphed here in red. And let's just say we have an x value of 4 or an input value of 4. So that would give us an output value of 2. And so if I were to graph that, it would be this point here in red, 4, 2. Okay, so now if we were to take the inverse of this function, we would get this graph here in blue. So again, notice that nice symmetry around the line y equals x. Now again, the point on this graph will have these coordinates flipped. So input and output are flipping. So the point on the blue graph, or the inverse graph, is going to be 2, 4. Of course, we could also verify that algebraically by just taking y equals x squared Again, just plugging in 2 here, y equals 2 squared, which equals 4. So again, that gives us that point 2 comma 4. Okay, so now let's go ahead and find the slope of our original function at this point. So y prime, when we have the square root of x, is just going to be 1 over 2 root x. Hopefully you all have this memorized. If not, feel free to pause it, take the derivative, and come back. All right, so now if we're finding y prime of 4, we would get 1 over 2 times the square root of 4, which is the same as 1 over 2 times 2, which is just 1 over 4. So again, what that's telling me is the slope at this point is equal to 1 over 4. Okay, now let's go ahead and find the slope at our reciprocal point. So now let's go ahead and take the derivative. So the derivative of x squared, let's just call this g again. So g equals x squared. So g prime is equal to 2x. So again, we have to remember that now our input and output have flipped. So now our x value is 2. So g prime of 2 is equal to 2 times 2, which is equal to 4. So once again, we've demonstrated that the slope at the inverse point is just the reciprocal of the slope of the original point, which is the whole idea of this lesson of differentiating inverse functions. Okay, let's take a look at a couple of examples to make sure this all makes sense. Okay, so let's take a look at number 1. It says, suppose f is a differentiable and invertible function with f of 2 equal 5, f prime of 2 equal 3, and we are trying to find the inverse derivative of 5. Okay, so let's talk about this in the same way that we went through our example. So I'm just going to kind of draw a very rough but simple graph. So first of all, for our main function f, we're going to use the color red. So this point would just be 2 comma 5. Let's just put that point here. And then what do we know about that? Well, we know that the slope of 2 is equal to 3. So what we know is that at that point, our slope or our m value is equal to 3. So now what we are looking for, we're looking for the inverse slope of the input value of 5. So first things first, let's just plot our inverse point by basically just flipping our our input and output values. So that would become 5 comma 2. So let's just put that point right around here. So this would be 5 comma 2. And now you should already know just from going through the previous lesson that our slope at that point is going to be the reciprocal of this slope. So my slope here is going to be 1 over 3, which would be answer choice B. Okay, let's go ahead and move on. Okay, so for number 3, it says let y equals the inverse of f of x, where f of x equals x cubed plus 3. And we want to find y prime at x equals 2. So the interpretation of this question is really important, and I'm going to really try to use input and output so that we don't get too confused here. So first of all, it's important to just understand what we're looking for. So basically, we are looking for the slope of the inverse function when the input value is 2. So again, the slope of the inverse function when the input value is 2. Okay, so now let's go ahead and talk about how to do that. So first of all, we know that for the inverse function, so I'm actually going to label that in blue. So for the inverse function, we know that we have some point 2 comma something, right? Because we know that x equals 2 for our inverse function. So what that tells us is for our original function, we are going to have an output value or a y value of 2. So first step is to just figure out what our x value would be. So how we could basically output 2 here. The easiest way to do this algebraically is to use the rational root theorem. So basically, if we set this equal to 0, you'll have to remember this from your pre-calc class. Basically, all possible roots are plus or minus negative 2 over 1, which is just plus or minus negative 2. So you'd have to go through using synthetic division and check 1, negative 1, 2, and -2. However, it's kind of easy just to go through those in your head, just using this equation here. Again, just checking x equals 1, -1, 2, and -2. I think it's pretty easy to see that the only possible x value here is 1. But again, feel free to pause, go through it, and prove it to yourself. So I'm going to go ahead and just tell you right now that our x value would be 1. And so what that tells us is that our inverse function here, this would have an output value of 1. Remember, it's that same idea of always flipping x and y. So now, going back to our original function, our f of x, let's go ahead and take the derivative to find the slope. So we would get f prime equals 3x squared plus 1. So now, again, we have an input value of 1. So f prime of 1 is equal to 3 times 1 squared plus 1, which is just equal to 4. So we know that the slope at our original point would be 4. However, we are actually looking for the slope of our inverse function when our input value is 2. So again, we know that it's going to be the reciprocal of 4, so it is going to be 1 over 4, which is answer choice C. Okay, so number 5 says, suppose f of x equals the natural log of x plus 2. What is the derivative of the inverse function evaluated at x equals 0? So again, most important point here is to actually understand what the question is saying. So basically, we are looking for the slope of the inverse function when the inverse's input is 0. Okay, so let's go ahead and set this up like we did last time. So we're going to have original and we are going to have inverse. So we know that our input value for our inverse function is 0, and we don't yet know the output, which is going to make our input value here unknown, but it's going to make our output value 0. So let's go ahead and first just figure out what this input value would be. So let's go ahead and just plug in 0 for y here into our original equation. That would give us 0 equals the natural log of x plus 2. And I'm actually going to just rewrite this as the log base e. I just find that that helps a lot of my students to kind of conceptualize natural log. And now I'm going to go ahead and just rewrite this in exponential form. So again, that would make this my base. So it's going to be e to the 0 power equals x plus 2. If that was tricky, you may want to go back and review log rules from like your pre-calc class. But anyways, let's keep going for now. And so now any number to the 0 power here is just equal to 1. So we would get 1 equals x plus 2. Subtracting 2 from both sides would give us x equals -1. And so now this is our input value for our original point. And so now going back to the inverse, that means our output value for our inverse point is going to have a -1 here. All right, now let's go ahead and get our slopes. So let's go ahead and take f prime of x. So you do have to remember the derivative of the natural log. You should have that memorized. So f prime is going to equal 1 over u times u prime. Again, I'm just using the derivative of the natural log using the chain rule. And basically, I kind of just skipped this. I didn't explicitly write it out, but u equals x plus 2. So basically, I had the natural log of u, and then I took the derivative here. And so now plugging back in, I would get 1 over x plus 2 times u prime, which is just 1. So that would give me 1 over x plus 2. All right, now again, my x value here is -1. So I'm going to go ahead and plug that in, and I'm going to get 1 over -1 plus 2, which is the same as 1 over 1, which is just 1. All right, and now going to the rule, the inverse slope at that point is just the reciprocal of 1, right? Because that was my original slope was 1. So the inverse is going to be the reciprocal of that, which in this case, 1 over 1 is still just 1. So my slope of my inverse function at x equals 0 would be 1. Okay, so for number 7, it says, if y equals the inverse of f of x and f prime of 4 equals 5, f of 4 equals 9, find y prime at x equals 9. Okay, so again, we have to be careful with our interpretation here. What we are looking for is the slope of the inverse when the input of the inverse is 9. So let's go ahead and set up the problem again. So I'm going to label this as original and inverse. So again, for inverse, I know my input is 9 and I don't yet know my output, which is going to mean for my original function, my output is 9 and I don't yet know my original. All right, however, this question is a little easier because I'm actually given it here. So I know that when my input is 4, my output is 9. So I'm just going to go ahead and make that a 4, which is going to make the output of my inverse function also a 4. Now, again, here, I also know that my slope at this point is 5. So that tells me the slope at my inverse function is going to be the reciprocal of that of 1 over 5. Of course, we could also do this graphically like we did in the first example, right? So I would have my point, which is 4 comma 9, and I know that my slope here is 5. And then my reciprocal point we know is 9 comma 4, maybe here. And then I know that my slope is going to be the reciprocal of 5, which is 1 over 5, which is answer choice A. Okay, number 9 says, let f of x equals x plus sine x, and g of x equals the inverse of f. And we want to find g prime of 0. So just to kind of reiterate that, we want to find the inverse slope when the input to our inverse function is 0. Okay, so let's go ahead and set this up like we have been. So we have original here in red, and then we have inverse here in blue. So again, our input value here is going to be 0. We don't yet know our output. And then here, our output is going to be 0, but we don't yet know our input. So let's go ahead and just set this up to start. So we are going to set our f of x equal to 0, our output value, and it's going to equal x plus sine x. So there's really no easy way to solve this. You kind of have to put the clues together. So hopefully at this point you will have your trig functions memorized and what they look like visually. So the way that I would do this is I would just subtract the x from both sides. So I would get negative x equals sine of x. Now, if I were to just graph these, I know that sine of x looks like this. So that is sine of x. And then I also know, I'll do this in green, that negative x would just look like a line like that. Of course, this isn't a scale, but this is a pretty good idea. So immediately the test point that I'm thinking of is right here, which is 0, 0, because that's the only place they're going to intersect. So let's go ahead and just verify that by just testing 0 there. So if I were to go ahead and plug in 0, I would get negative 0 equals sine of 0, which would just give me 0 equals 0, and that checks out. So that tells me that my input of my original function is also going to be 0, which tells me that the output of my inverse function is also going to be 0. So now let's go ahead and find the slope at this original point. So f prime would just equal, the derivative of x is just 1. The derivative of sine is just cosine, so just cosine x. Now we're going to find f prime of 0, which would just give us 1 plus cosine of 0, which is just 1 plus 1, which is 2. And so that tells us that our inverse slope here is going to be the reciprocal of that, which would be 1 over 2, which would be answer choice C. Okay, so question number 10 says, let f be a differentiable and invertible function. Selected values for f and f prime are given in the table below. Find the derivative or the slope of the inverse when the input value is 4. Okay, so let's go ahead and set this up. So we're going to go ahead and set it up like we have been. So we're going to put the original information here and the inverse information here. So again, our input value is 4, and we do not yet know our output value, which makes our output value of our original function 4. So going up to our table of values, we see that the output value of 4 corresponds to an input value of 1, which again is going to tell us for our inverse function that our output value would be 1. Now we have to find the slope of the original point, which would just be f prime of 1, which according to the table of values here would just be 7. And so that tells us that the derivative of the inverse function is going to be the reciprocal of that, which is just 1 over 7. Okay, now let's go ahead and take a look at an FRQ. So it says, let f be a differentiable function such that, and then it gives us this table of values. So for part A, we are asked to find the slope of the inverse function when the input value is 5. So again, let's go ahead and just set this up. So let's just set up our original values here, and let's set up our inverse values here. So again, the input of our inverse function is going to be 5, which makes that the output of our original function. So let's go ahead and take a look at our table of values. So the output of our original function is 5, which makes the input 2. So going back to the inverse, that's going to make our output here 2. So now let's go ahead and take a look at the slope of the original equation, which again is just given by f prime of our input value of 2. So that's just going to be equal to f prime of 2. So going back to our table of values, when x is 2 here, our slope is 3. And then going back to our inverse function, we know that the slope of the inverse is going to be the reciprocal of that. So we know that our slope here is going to be 1/3. Okay, now let's go ahead and move on to part B. So we've kind of already done this, but I'll just kind of reiterate it. So it says explain what this value means in terms of the graphs of f and f prime. So basically what that means is the value we found in part A, this 1/3 here, it represents the slope of the tangent line to the graph of the inverse function at the point 5, 2. That slope is the reciprocal of the slope of the tangent line to the graph of our original function f at the corresponding reflected point of 2, 5. Since the slope of f at 2, 5 is 3, the slope of the inverse function at the reflected point 5, 2 must be the reciprocal, which is 1/3. All right, hopefully that made sense. Thanks so much for watching, and I'll see you in the next one.